what is the Lewis structure? So we want the Lewis for XeF2O. So xenon fluoride oxide, okay? So this is going to be a little bit tricky, all right? Because xenon typically wouldn't care about making bonds because it's a noble gas. But let's solve this nonetheless. Let's see how we can work with this. In theory, xenon then will most likely be breaking the octet rule. But let's see how. So we have xenon, which is on the 18th column, so that's 8 electrons. It's using 8 valence electrons. And fluorine, 17th column, but there's 2 of them, so that's 7 electrons each, so that's 14. And oxygen is in the 16th column, so that's 6. So 8 plus 6 is 14, plus 14 again, that's 28 electrons total. So because xenon is the one that can break the octet rule most comfortably, I'm going to put that one in the middle, okay? And the reason why I say that, because even for it to even be involved in this Lewis structure, it has to already break the octet rule. So I'm going to use that to say that it's going to be in the middle with the benefit of the doubt. So xenon, and now, because now I'm going to actually put, it's going to be 1 bond each for the fluorine, and the oxygen. So fluorine right now is sharing 1 of its 7 based on this single bond here. So 2, 3, 4, 5, 6, 7. Same here. So these two are already complete. Finish your octet rules. Oxygen is sharing 1 of its 6. So 2, 3, 4, 5, 6. So there's going to be 1 unpaired electron right now. Xenon, on the other hand, is sharing 3 of its 8. So there's going to be 4, 5, 6, 7. Actually, let me do it here. 6, 7, 8. So there you have it. Actually, let me put it up here. We have right now 1 unpaired electron. Okay. So with that being said, these 2 unpaired electrons are going to go ahead and form another bond. So between the xenon and oxygen, it's going to be a double bond. All right. So if we redrew this, we have now xenon double bonded to this oxygen. Okay. And we have the fluorine here, a fluorine here. Oops, too close. Almost for the actual bonds. So fluorine here, fluorine here. All right. And there we have it, but not quite. We want to make sure we actually finish up the xenon. So as you said, there was a bond here. It's going to have just an extra bond. This I'm going to write it over here like that, just so we can make sure we know it's the extra one. Same thing with this one. I'm going to do that. So with that being said, though, that means that, in fact, I'm going to make this one red as well, because technically speaking, as you can see, it already, the blue ones are where the octet rule is, and the red is where it's going beyond the octet rule. So I just give that the oxygen xenon pair is the one that's following the octet rule. All right. So now if I calculate the formal charge for each one, fluorine should be relatively straightforward. It's going to be the 7 valence electrons, and it has 6 electrons to itself, sharing just 2. So we do have 0. Okay. Xenon, 8 valence electrons. All right. It has 4 to itself, but it's sharing 2, 4, 6, 8. So that's 4 plus 4, 0. So that's perfect. Oxygen has 6 valence electrons. It has 4 to itself and sharing 4. So this is going to be the Lewis dot diagram for this indeed, because we've shown that the formal charges are good. And let's count the amount of electrons we have now. We have 8, 8, and then 8. So that's 8 times 3 is 24, plus 2 plus 2. That is indeed 28 electrons. So, as they drew it. They do have a double bond there for the oxygen, which is what we had, and they filled in the electrons. So as you can see, those two that I added break the octet rule, which is what they have here, but everything else is following the octet rule. So this is correct. And they also use the formal charges to be able to justify why they broke the octet rule, because the goal is to have 0, especially when dealing with a neutral molecule. You want to have 0 for everything. So by us being able to even calculate 0 for xenon, that shows that it would prefer to have that formal charge of 0 rather than to just strictly follow the octet rule. Okay, so now let's go on to question number 15.